Hello, everyone. My name is Merle Massey. I'm the coordinator for undergraduate research here at the University of Saskatchewan, and I've been coordinating our pilot project SURE program. Thanks very much to Kevin Reed of the University of Saskatchewan, who is joining us today to present on research data management. That's all from me. Kevin, over to you.
Okay. So hi, everyone, and thank you for coming and for showing interest in a topic that I think has just started to gain traction over the past few years. As Merle said, my name is Kevin Reed, and I'm a new librarian at the University of Saskatchewan. I've only been here since October of last year, but for the previous 8 years, I worked predominantly in helping researchers manage and share their research data in the health sciences. So I previously worked at NYU School of Medicine, and before that at the National Library of Medicine at the National Institutes of Health. So hopefully I can give you some perspective today, and you can learn a little bit about a topic that you might not know as much about before. So the plan for today is really to help you articulate why data management is important, to describe some incoming requirements around research data from the Canadian tri-agencies as well as publishers. So if you're thinking of publishing, what you might need to do in the future to help you apply methods to improve the transparency of the research process, and for you to identify some institutional and external tools for managing, storing, and sharing your data. So what I want to start off with, I think can be really helpful because data management can be abstract at the very beginning, is I want to show you this recipe for heavenly pie. So you'll see here we have a list of ingredients and we have a very limited set of instructions. So all I get from this recipe is put in shell, put cream and chopped nuts on top. So maybe Ms. Sycophus has a really good idea of what it looks like of the finished product for this heavenly pie. But based on the instructions that I'm seeing here, it's not entirely very clear to me what I need to do to put that in the shell. Am I putting raw egg whites and sugar into this shell? What kind of shell am I putting it into? What does T mean? Am I talking teaspoon or tablespoon? Same with C. So you see here, there's a lot of lack of clarity. Now, if we think about the research process and our heavenly pie as the finished heavenly pie, as our published journal article, you can think of this recipe as the methodology underlying that research article and the ingredients as the data, as what I'm using to inform and create this pie. And if that information isn't accurate or it isn't clear to me, it's very hard for me to tell how someone came to the final results in their published article in terms of what they did. And so when we think about data, I want to first of all start off the idea of data can mean many different things to many different people. And the easiest way to break it down is into quantitative data and qualitative data. Now, quantitative data would be basically understood as numbers. So that might be geographic coordinates. It could be information from electronic health records like blood pressure or heart rate. It could be economic projections in the stock market. It could be environmental statistics on climate or survey data. And qualitative data is non-numerical. So that might be interviews with people, open-ended survey questions, me observing the actions of somebody else and recording them, providing oral histories, or even just generally looking at historical papers and bringing that information in and synthesizing it in some way to report in a journal article. Data can also take many different forms in terms of how you're collecting it. So there's primary data and secondary data. Primary data is usually collected firsthand by you. It is entirely original. And an example might be you collecting data observing migratory bird patterns in Argentina. It's you sitting in that field. It's you observing the specific information of those bird patterns and you recording that information. Whereas secondary data might have been collected by someone else entirely. It may have already been analyzed and distributed and shared by someone. And examples of this Canadian federal data sets that come out. So the Canadian Community Health Survey is there for you to take and use and analyze and interpret for your own research, but the data has already been collected in some way, shape, or form. And so when we think about the research process, we have lots of different stages. We have everything from hypothesis planning to designing our study, to collecting our data, to publishing. And ultimately, the goal is to publish and to create that peer-reviewed article. But when you think about the peer-reviewed article from the perspective of the data management process, that publication is just the tip of an iceberg. So if we're thinking about an iceberg where probably 80% of it is below the surface, the 80 or the 20% in that publication is the summarization of everything you did and reporting the results of that. So what I want to focus on today is all of the other information that might be useful for somebody below the surface. So what is data management and what does that mean? Really, it's how you plan and document all aspects of your research project. So that might be the study design that you choose to use, how you collect data or specific information for your research project, how you analyze that data and transform it into something that you share in a publication or a presentation. And ultimately, what data management is making sure that your data and everything underlying that paper can actually be understandable by others so that it can be either be reused, reproduced potentially, and or shared. And I'm going to talk a little bit more about those terms a little bit later, but the idea is that everything underlying your process is understood and clear to someone else. It's transparent. So there was a really great article that came out in Nature a couple of years ago called Everyone Needs a Data Management Plan, and calling it really an essential product of research. Because obviously you start the research process, you start doing your work, but oftentimes as we do the work, we forget about the idea of documenting what we do and how we do it. Inherently, inside, we know exactly what we did and how we did it, but that doesn't mean that that's going to be understood by somebody else. So if we think about the research process, each stage of this process has a lot of elements to it that might want to be incorporated into a data management plan. So at the hypothesis stage, you're thinking about your research question, you're developing a hypothesis, you might even be drafting a protocol for what you're going to do throughout the research project. During the study design and collection phase, you're documenting what you do, you're collecting information or data, you're organizing that data, you're storing it somewhere, and you're preparing it to be looked at in a different way. You're then analyzing it, you're documenting your findings, and you might even be saving code. Any of you who are working with programming languages, you might be running scripts in tools like R or Python, for example, which are different statistical software programs, and you ultimately want to be capturing that as well, all for the goal of publishing, which means you might be generating figures, you might be preparing data to be shared, and you would be compiling all of that documentation so that it could be understood by somebody else. So again, we think about the publication there as that 20% above the surface that summarizes everything we do, but below the surface, there might be our study protocol, how we plan to collect our data, code books so that our data is understandable to somebody else, an analysis plan that shows how we did what we did, any software we used, and any code we might have run to actually create that data. All of these things should be in your mindset as you're doing your research process as essential products of information that substitute or supplement, pardon me, your publication. So the worst thing you could do is you get to the end of your research project, and this happens to many, many people, and someone might say, hey, I found your findings pretty interesting. Can I see your documentation and can I see your data? And you think to yourself, oh God, well, here's what I have. And this is often the case without data management. You're just left with a lot of piecemeal pieces of information that might all be there, but is extremely hard for people to understand. It may even be hard for you to understand even a year later after you've completed a research project. So there's a really great article by a colleague of mine at Stanford University. It's called Support Your Data, a Research Data Management Guide for Researchers. And on the left-hand side, what we have here are all of the stages of that research process. So planning your project, organizing your data, saving and backing it up, getting it ready for analysis. And on the top, we have the different levels of data management that people tend to take. So in the planning your project phase, we can see an ad hoc way to think about this is when it comes to my data, I have a way of doing things, but no standard or documented plans. Whereas when we move to the furthest side of the page, which is optimized for reuse, meaning someone could take my data and reuse it for something else, I've created plans for managing my data that are designed to streamline its future use by myself or others. So we have one stage, which is I'm doing it as I go, and if I think about it. And on the right-hand side, I'm doing it in the sense of I'm considering other people who may want to use this later. Now, most researchers probably fall into this category. So either ad hoc or one time. They're not thinking about data management at the outset of their project, And most likely they're doing it because they've been asked to do it or because they might think about it on an ad hoc basis. But ultimately, what we're trying to do, and I think what research in general is trying to move people towards, is how do we make sure we're documenting all this information with others in mind? So why is data management important then? First of all, it's going to help you avoid errors in your research. Can you locate your raw data? So if you're creating figures for a publication as part of your research process, is it easy for you to find the data that you used to create that figure? That, again, that could be numerical data, that could be historical papers, but basically you want to make sure that it's easy for you to find information to support any arguments that you publish or create in the wild. Is it easy for you to connect related data? So if I'm working in a health field and I'm taking brain scans, I'm running surveys, and I'm looking at genetic data of the same patient, is it easy for me to take these different kinds of data and make sure that they're connected? So I know exactly what data is from which patient, and it's easy for me to synthesize and organize in a certain way. If I'm working with other people in my research team, are we calling the things that we use the same thing? So this was an example that happened to me a lot when working at NYU, was I would go into a lab that was studying rats, and different people in the lab would be calling that rat a different thing. Even though it's the same rat, they had different naming conventions. And when it came time to look at the data, it was really hard for them to figure out and match which data came from which rat because everyone was calling it something different. And then finally, we have the worst case of when data management can be a problem is that you can actually have papers retracted. So there's a great website, and I recommend if any of you haven't heard of it yet to take a look. It's called retractionwatch.com. And what it does is it highlights all of the different reasons why research papers have been retracted over the years. And here we have an example from a geneticist who was a graduate student and postdoc and published 4 papers when they were doing so. And ultimately, there was huge problems with their data that they couldn't replicate because they couldn't find their data. And so all 4 papers were retracted, which could really be a black mark on your reputation as a researcher. So in this case, the researcher responded, errors came from very early steps of preparing their figures in that process. They weren't able to find their original data. And it turned out the main cause of this was because they had really bad data management practices and bad organization. So something as simple as just keeping your data organized and easily accessible fell by the wayside for this researcher, and they lost 4 papers because of it, which is a huge impact. And now what we're seeing is if you want to be funded by the Canadian government going forward, data management is becoming a requirement. So one of the things that they're requiring that you do is you submit a data management plan if you want to apply for grant funding. This means that you'd have to describe how you're collecting your data, how you're documenting it, how you're formatting it, protecting it, and preserving it. Are you going to be using existing data sets? How do you plan to share the data? Where are you going to put it? And who's responsible for that data? And remember, in a data management process, what's really important is often people will say, well, everyone's responsible for data management. But as soon as everyone's responsible, it really means that nobody is. So very important that you think about whether it's you or communicating with faculty members, that someone needs to be responsible for making sure everything is understandable and usable. The other part of this is a commitment to deposit your data. So grant recipients are required to deposit into a recognized digital repository. I'm going to talk a little bit more about repositories later, but basically it's a location online where someone could take and access your data and use it for something else. And that's the data itself, the information that you use to understand the conclusions of what you shared. So either that's a journal publication, a preprint, or a presentation. And ultimately, this is going to make your information more available. We're also seeing this call from publishers. So if you ever want to publish a journal going forward, a lot of journals now require that you share all the underlying information in your manuscript or in your published article. So PLOS, for example, says if you refuse to share, we will reject your article. It may be amazing science. It could be the best research we've ever seen, but if you refuse to share your data, we won't publish you. So really important to keep in mind that this is really coming in from a lot of different angles, and it's an important process to consider. The The other issue is that now, as people are starting to share, a lot of that data is unusable. So there's a great article in the New England Journal of Medicine called Avoiding Data Dumpsters. And what happens is, let's say I'm working in an Excel spreadsheet and I share my spreadsheet with you. You have no idea how that spreadsheet was generated. You don't understand the experiments that I ran or what I did to that data. And ultimately, it becomes useless to somebody else. And so that's why data management is so important, because when you share your data, all that other information that you've already documented and kept track of is going to make your data more understandable to other people. We also know from recent studies that the continued value of research data declines rapidly over time. So as soon as a journal article is published, all the data underlying that publication starts to degrade. And that might be because it's not being preserved correctly, or maybe the author of a publication isn't minding the data as much, they're not really paying attention to it. And so ultimately, it starts to lose its value and it starts to become unusable as the years go on. And that's a problem. And a big issue with that is because there's no documentation to help understand that data better. We're also seeing in some areas of research that there's a reproducibility problem. And I'm going to caveat this with not every area of research has a reproducibility problem, because there are certain caveats with that. But in biomedical research and some of the sciences, what we're finding is a lot of published papers cannot be reproduced in a way to see if the findings are valid or not. And that's a huge problem, because patients provide their time and their health to a lot of clinical trials and a lot of research, and it's not being done in a way that can be represented or trusted. And that's a problem. Now, reproducibility doesn't happen in a vacuum, and it doesn't happen in every area of research. If you're studying astrophysics, for example, or if you're studying meteor showers, that can only happen at one point in time, and you can't reproduce an experiment because you never see the same meteor again. But in certain areas of research, the baseline for this is that you want to make your research transparent so other people can reuse what you do. We're also seeing that when there's a world event that may be happening right now, such as COVID-19, that data sharing is becoming extremely important. If we're trying to get rapid vaccinations and deal with public health responses, data management is key, because if we're sharing data that's unusable, it's not going to help us get to the common goal. So data management is a key underlying component to making research more available and understandable to others. I'm just going to stop for a second and see if there are any questions in the chat. You're welcome to use the chat. You can also interrupt me if you need to. Are there any questions? I'll also take this moment to take a sip of water. Okay. I will continue. Again, if you have a question, please feel free to interrupt me. So thinking about data management and the research process, what I want to do is think about, what does good data management look like? And there are a number of things that you can consider that will help you throughout your research project make sure that your data and your research process is transparent and understandable to others. The first is a data inventory, which I'll go into in a little bit. A strategy for describing how you got the information or data that you collected. A plan to make sure that your data is preserved, not only for the next year, but maybe the next 5 or 10 years. And a method for ensuring that someone else can access your data. So there are a set of principles that came out a few years ago that are being used mostly by publishers and by research communities, called the FAIR principles. And that means that what they want to make sure is that if you have research data, that it's findable, meaning that I can search somewhere online and be able to find it. It's accessible, meaning I can actually then, once I've found it, I can take that data and maybe use it. It's interoperable, meaning I could take my data and someone else's data and combine it, and it would be easily done. And finally, it's reusable. So it includes documentation and information about where it came from, and I can take that data and have enough information to reuse it for my own purposes. So a data inventory includes a number of different elements that are important to consider at the very outset of your project. First of all, what are the types of data you are collecting? Where is the data coming from? What does it look like? Is it primary data? Is it secondary data? So is it my own data that I'm creating, or am I pulling data from somewhere else? It's important to document all of those things. The second are, what are the file types I'm generating from this type of data? Am I looking at Excel files? Am I doing everything in Google Docs? Or am I using a really specific, unique type of software that's only available in a certain lab? Keeping that into account is going to help inform how you work with that data later on. You also want to think about how stable is your data or your information in its original form. So what I mean by that is once you've collected it, are you done with it? Or are you going to be changing that data every week or every day? And so thinking about how often you update that information is a really important facet as well. How much data are you going to be generating is a really important thing to ask yourself because you want to think about where am I going to be able to store this data? And then finally, what else is going to be created throughout my research project that is going to be necessary to understand my data? So I've mentioned this before. Maybe it's codes, maybe it's my lab notebook, maybe it's a template I built, or maybe it's protocols. And again, when you're thinking about the type of data you're collecting, just make sure you're accounting for all the different types. So an example here might be a set of interviews that I run. So maybe I'm doing some sensory recordings of a patient and I'm running transcripts and administering surveys to the patients. I'm generating MP4s from the interviews. I'm recording my information in a Microsoft Word document. I'm saving my information in a CSV file, which is another type of spreadsheet. And I have some ASCII files for some of the recordings I have. I'm not modifying my data after I've collected it. And I'm going to be doing 50 interviews and I have 500 megabyte audio files for every interview, which means I need about 25 gigs of space. And then I'm doing my analysis in SPSS, so I'll make sure that I keep the scripts and the files. And then something else someone might want to know about my data is the questionnaire that I used, the protocols that I used to set up the interviews, and hey, I'll throw in a use guide so people can understand how my data was used. So the inventory is there to give you a big picture of what it is that you're doing and the types of content you're going to be generating throughout your project. And documentation is really the most important part of data management. So some key considerations to think about when you're incorporating research data management into your study design is always ask yourself, will my data make sense to somebody else? And will someone else understand how I collected it? So one of the things you could do is think about describing your experiments in detail. Where is your data coming from? How are you collecting it? What are you measuring or testing or examining? And what software programs did you use? And not just the program itself, but the version that you used as well. And one thing you can do is build a collection plan. So this could be narrative. So in this case, on the left-hand side, I have my own research protocol or data collection plan of what I've been doing for my own research. And it goes step by step through everything that I do. Another really valuable thing you can consider is developing a visual workflow diagram. Because people are often visual learners, it's just a helpful way to get a better picture of how you're doing what you do and why. The other thing you want to think about is once you've collected your data, is it actually going to be understandable to someone else? So if I shared this spreadsheet with you, you would have no idea what P1, P2, P3, P4, P5 mean, or what the numbers underneath the spreadsheet mean as well. And just so that all of you on the call know, this is a real world example from a medical researcher at NYU who let me share this. And so I might know as the researcher, or that researcher might know what P1 means. If I gave this to you, it would be totally unusable. And so ultimately, what you need to think about if you're going to be creating lots of spreadsheets, for example, is that you think about describing your data. So list all of your variables and provide descriptions of what they mean. How are they represented? Is it a string of words? Is it a scale from 1 to 10? Is it an integer? So is it a number, for example? Or are you building categories? And what are your units of measure? Very, very important and often extremely overlooked by people. When you're doing certain kinds of research, let's say you're measuring the weight of somebody, oftentimes researchers will leave out that they measured it in pounds versus kilograms. Or if you're in the UK and you're working in an archaic system, maybe they're measuring in stone. So it's just really important for you to think about how you're collecting and describing all of this. And once you've thought about it, you can use something called a data dictionary. And what the data dictionary is for any kind of spreadsheet that you share or that you're creating, you should have a dictionary that goes along with it. So you'll see here On this side, we have the name of the variable, which might or might not be understandable to someone, but right next to it is the description of what that variable is, the type of data, so we have a number or a character, which is valued by n or c, we have the width, and then we have the values. So we can see that 1 in this case equals English and 2 equals Spanish. So anywhere that your data goes, if it's in a spreadsheet, the dictionary goes as well, because I can always use it as reference if I'm not sure what it means if I go back to here and I don't understand what 1 means or what 2 means. Okay. Something else that is extremely helpful and can take you literally 5 seconds to do is create README files for your data. So a best practice is create one README file for each file that you create. Make sure that it's named almost the exact same thing. So if I have a file that says Kevin data analysis plan, the next file would be Kevin data analysis plan README. And you write your document as a plain text file so that it's easily understandable to other people and they can open it up in any format on any computer. And keep the format of your files identical. So what should they include? A short description of what's in the file, how you collected the data, whatever it might be, information about anything related that someone might want to use for reference or software that you used, who was involved, and how the data set should be used or analyzed. So here's a really simple example. So basically what I'm using a README file for, and that's a great question, is ultimately the README file is the guide. It's the instructions for each individual file. So that if I share the file with you, it might take you 20 or 30 minutes to figure out what's in my spreadsheet, for example, whereas a README file is really the narrative description that tells you what's in it. So here I have an example where my file name was the raw data from my library survey, and I created a README file on top of it. So the description is this file contains survey responses from 40 librarians working in academic health sciences libraries in Canada and the US. And my methods was I collected data from September 1st to December 31st. I used REDCap to collect the data. And then I used NVivo software and the specific version that I used. Remember, anytime you use any type of software to record and make sure you document the version, because if NVivo comes out with version 15, my data might not work on that version. So you want to make sure that people know exactly what you used to reuse or reproduce what you did. Then because people might want to see what I did with this raw data, I have the other files they might want to look at. I tell them where the survey instrument can be found, and then it says, I was responsible for administering the survey, and my colleague Susie Q analyzed the data in NVivo. So really, this is a very detailed README, but it can really just be a description and who's responsible, so I know who to contact. Once you have that all set out, so you have your data inventory, you have your documentation, you're building a data dictionary, now it comes time to organize your data. So generally, file organization is somewhere that falls by the wayside very quickly. It's something that if you don't think about at the outset, can easily turn into a giant mess. It's happened to me thousands of times. And it's taken a long time to practice in order to get this right. So when you're thinking about your project at the very beginning, again, what are you creating? What are the types of files you're creating? Remember your data inventory. How could you group these files? And what is the workflow for adding or moving files? So every time you create something, where's it going to go? Where's it going to live? How are you going to make sure that it's there and accurate? Ultimately, one directory or one file per project is best practice. So I have one folder for my project, and I separate out my components I have a folder for my raw data, which means data that I'm not going to touch, but I might copy and do something to. I have my process data folder. I have a folder for any code, and then outputs. So outputs might be my survey instrument or my historical papers or my code book. And then finally, make your original raw data read-only. So what I mean by that is, let's say you have your master data file, you've completed your project, but what you want to do is start looking at that data in different ways. You always want to keep one raw copy of your data that never changes, because if you start to change things, you can never go back to the original. And then again, every folder or every file should have a README. Now, I know I'm providing a lot of different contexts and a lot of options for documentation, but really, if you only do some of this, it's better than doing none of it. So starting out slowly and getting comfortable with this is really the best way to start. But any organization is better than none because as soon as you have no plan, it gets very hard for you to go back even 4 days from now to say, why did I create this file? What does it mean? I don't remember anymore. The other thing, and this seems like a really, really simple thing, but I think again is a part of data management that people don't think about and don't have a plan for, and that's file naming. So here we have an example of a file, and we have what looks like the word gene and expression, maybe round one, and I have something that looks like a date on the right-hand side. So in the chat box, what date do you think this is? If you had to guess what the date was. December 6, 2011, possible? Yeah, exactly. So, and that's the exact point, right? So if date is important to me, maybe it's June 12th, 2011, maybe it's December 6th, maybe it's January 26th. And if I'm going to be dating my information, you need to think about using a consistent, understandable language. Now, the easiest way is to use standards to do so. So the International Standards Organization has a way to search for dates, and that's year, month, day. So again, keeping that in track will always make me understand what it is. And again, if you think someone might not understand it, you can have another README file that says files are saved as this name with this date, and this is how it's recorded. When you're file naming also, you want to be descriptive. File.text isn't going to tell anybody what it means that's in that file versus 2018-09-20 mouse weight probably tells me that this spreadsheet talks about mouse weights recorded on that date. I know there's probably many of you, including myself, who've put final, final, final on their copy, but ultimately you want things to be unique and descriptive as much as possible. It should be human readable. You also want to think about machine readability. So sorting or pulling data into different places should be easy for you, right? You want it to be easy for you to find the information that you need in a folder. I don't know how many times I've opened up a folder and spent too much time looking for something because I didn't name something properly. So the more consistent you are, the easier it's going to be for you to go back and find the data or the information that you need. Also, avoid using abbreviations. So nobody is going to understand your acronyms, maybe not even you. So making a bunch of gobbledygook or thinking that you might understand something later is probably not going to be a reliable way for you to name files. So in general, you want to avoid using spaces because let's say you pull files into a certain program, it might not understand it. So dashes are great, underscores too, and camel case, which means you capitalize each letter, can also be an effective way to do this. You also want to avoid using special characters. So any special characters can break any type of software program. So in general, you want to avoid using them and keep it to letters, numbers, underscores only. And again, think about version control. So if you know you're going to be creating 100 separate data files, you'll see here on the left-hand side, if I just put a 2, it's going to start to sort really poorly, right? Because it's going to take the 1 first. Whereas if I account for all of the numbers I need up to 100, and I put 00 in front of it, my data is going to sort extremely well in any type of file format, which will make it easier again for me to find. Any of you who are interested or are currently working on research and are thinking about renaming, it can take a long time to rename all of your files, especially if you've been working on a research project for a long time. But these are some really great tools you can use to rename all your files in bulk. So it's really great. There's 2 free options, one for Mac and one for Windows. And then Renamer, which is probably the best, costs a little bit of money, is another great tool to use. So highly recommend. File naming is really a huge headache, but this can be a really easy way to move forward with that. So once you've collected everything, it needs to be stored somewhere. And there are lots of options for storing your data. But ultimately, there are lots of options here, and you need to think about what kind of data you're collecting. So if it's public use data, there are lots of options at the university for you to use. Whereas if you're collecting restricted data, which means it might have personal health information in it, or sensitive data about someone, or financial records about an institution, you're more limited in what you can do. And you need to consider thinking about caring for your data in a different way. So always be thinking about and cognizant of what's in my data and what should I do with it. When you're planning for data storage, again, remember your inventory. You want to think, how much storage do I need? Where am I going to put it? Document where your data is going to live throughout the project. So if I'm going to be collecting all my data in the beginning in a tool like SurveyMonkey, then that's fine, but I want to account for that. And then I want to take that data out and I want to put it into an Excel spreadsheet. Where's that data going to live? Sometimes it's going to be on SurveyMonkey, sometimes it's going to be somewhere else. So really important for you to think about that. Plan ahead so that every time something new is created, you know where it goes. And then think about, again, who's responsible. So maybe I'm the one responsible for conducting the interviews and putting the data in, but maybe I hired someone to do the transcripts. And who's responsible for that? So keeping people accountable is a really important aspect of the data management process as you work through. Once you've stored your data, you need to think about preservation. Now, just because you've stored something somewhere does not mean that you've preserved it. So if I have a USB stick and it's in my drawer, and it's in a box from when I've moved, that isn't good preservation. Sure, it's stored somewhere, but what happens if I lose it? I no longer have access to that data later on. So preservation is really there to help protect you from a number of things. First of all, we have hardware obsolescence, and second is software. So hardware obsolescence means that you're saving your data or your information on types of hardware or systems that no longer exist, right? So this, for example, is a Jazz drive. I'm not sure if any of you have heard of a Jazz drive before, but this is a colleague of mine's PhD thesis is on this Jazz drive. And because it's on this Jazz drive, the types of tools or products don't exist anymore to open this. So in hindsight, what she should have done is taken the data off this drive and put it into a format that can be opened in perpetuity along the future. The same goes as if you're using specific types of software programs. If your lab or your team has bought a specific kind of software that is only can be used within that type of software, you may not be able to open it up in a different kind. So you want to be thinking about the format you save your data in so it can always be opened forever and accessed forever. So thinking about file formats, there are proprietary versions on the left-hand side here, and you have open versions on the right, which is their equivalent. So Excel, obviously, super useful. It's been around for a very long time. You can do lots of useful things in Excel. But if you want to preserve your data forever, you would put it in a comma separated value file or an extensible markup language file. Because a CSV file, for example, can be opened by any product. It could be opened by Excel. If you use Corel WordPerfect Suite still, you can open a CSV. You can open a CSV in Google Drive. It's really there to be ubiquitous across any system. So what's important for you to think about is if you have data that is so valuable that you can never reproduce it or replicate it at another point in time, you better be saving it in an open format because that's going to ensure its longevity and its life over time. Again, think about the continued value of your research. We know that it declines, and one of the reasons is because formats no longer work as those years go along. So again, the more you can use open formats, the better. The other thing that's extremely important for you to do is you keep that one copy of your master data set. So that's read-only, you never touch it, it's always going to be the same. It serves as the final product of all of the hard work you've done throughout the research process. But then if you want to do analysis on it, or you want to open it in a different program, you make a copy of that file and you open it up in Excel, or you open it in SPSS, or you put it into R. And ultimately, what that's going to do is make sure that you always have that one version that has all the data. If I work only with these and I make changes, I can no longer go back to my master data set. Whereas by having this, I can create hundreds of copies and do different things with them and never worry about losing the original product. Very, very important to keep in mind. And if you take anything away from this talk, I hope it's this, that you save and protect your work as much as possible. There's also the 3-2-1 rule. So always keep at least 3 copies of your data. We rely a lot on the cloud now. So whether it's Google Drive or Dropbox, and that's great, but you should always think about having hard copies of your data and think about how often you need to back up that data. So if the data is really important to you, one of the rules that I apply to this is think about how much data you can afford to lose. So if I'm collecting data every day, but I'm only making a hard copy once a week, I risk losing a week's worth of data. So for me, I'd rather back it up every day. The other thing you want to do is store 2 backup copies on different devices or storage systems. So maybe it's on Dropbox, but you also have it on an external hard drive, and maybe it's on your laptop. And then finally, you want to keep at least 1 backup copy offsite. When I worked at NYU, it was during the time of Hurricane Sandy, and so many of our researchers at that time lost all their data because they had their laptop, their hard drive, all in the same place, and it all got washed underwater. So you should have your data at work, maybe in the cloud, and one at home, so that you always can be sure that your data will be recoverable and accessible later on. So once you've done all of this, you've planned your preservation, we've documented our research process, we're storing our data somewhere. Now it comes time to comply with some of those requirements, which means providing access to the data that you have. And when we think about our research process and we get to the publishing phase, the norm has always been, okay, I'm going to publish my paper, but now we're getting to the stage where it's, okay, you need to also make your data available as well. And where do you do that? And how do you do that? The first option is to think about repositories. Now, repositories are basically giant databases that allow you to upload your data online and receive a permanent unique identifier, meaning it will be a permanent place where your data can live and be accessed in perpetuity. There are institutional repositories, so the University of Saskatchewan or any other university you go to may have an institutional repository. The one here currently is called Harvest. You may also look at cross-disciplinary repositories. This is a hodgepodge of different kinds of research where anyone can share. And then finally, you have specific. So there are very specific databases up to for different types of research. So for example, there's one where people who study worms share all their data. So it makes more sense for them to put their data there because that's where their research community goes. And that's the lesson that I want you to think about when you consider sharing your data. The most important thing for you to consider is where are the people who you want to see it most likely going to go. So is it your institutional repository? Maybe, maybe not. Maybe you're working in genetics and you want to share with all the other researchers who are doing so. So you might choose discipline specific. But the important thing is the visibility of your data, because once it goes into this repository, you can receive credit for what you did. So just like you cite an article, you can cite the data as well and make sure that you're getting credit for all the hard work that you've done. What's really important is that different repositories have different types of and levels of service. So every repository is going to offer you storage. They will store your data and leave it there. Now, some will also offer access, meaning they'll make it available, and some will offer preservation, but not all of them. So before you choose where to share your data, it's very important to read what they will and will not do for you. The last thing you want is to put your data in a repository thinking it's being preserved for the long term, only for that data or that website or that repository to go bankrupt and close their doors. So you want to think about that. It's very important to consider. There are lots of great resources for you. Jordan, that's a really great question. And I would say it's advisable not to. You want to think about your data just like a journal article. So you couldn't submit your article to multiple places, and because ultimately that would be replication of your research. So you want to pick one place and leave it there. That's the goal. And oftentimes what you're seeing now is that when you publish your article, it will be directly linked to your data set. And I'm going to show you an example of that in a second. And so you need to make sure that that link is persistent and ongoing. So the decision that you make is really important because you want to make sure that you're choosing the right the first time. because that's where your data is going to live for the long term. So there are some really great resources for you of where you can put your data. Yes, Jory, that's a perfect example. That's a great segue for me. Further is definitely would be considered a cross-disciplinary repository. So one example that you can look at is read-free data. And what read-free data is a directory of all the different repositories for every field of research. It's not entirely comprehensive, but there are thousands of repositories in here for you to look for that you can search through. I highly recommend you taking a look at those. We also have the Federated Research Data Repository, which is FRDR. So for Canadians, this is becoming really one of the best places for us to share their data, because we know now that Canadians are going to FRDR to find research data from Canadian research. And in here, you will find everything from health data to humanities data to geography data. And it can be a wonderful place for you to share. And you can see here right on the right-hand side, you have the option to deposit your data right from the get-go. So a perfect example of a repository that's cross-disciplinary. So here's an example of a research project that I've done in the past and where I shared my data. And so here you can see I have my publication. I published it in PLOS, or the Public Library of Science. And from that publication, I shared my data in a tool called Figshare. I chose Figshare, to be honest, because it was easy to use and it was easy to set up, and it ensured that I got that unique identifier that I needed to make sure my data was persistent. And I liked it because I could see how many times people had downloaded my data, how many views it had received. And for me, it just seemed like a really useful place to put it. I also know, based on my own experience, that a lot of library researchers are using Figshare to share their data. So I assumed it would be an easy place to put it. So that was my decision process, and that should go into your process as well. I think the first and foremost is who's going to be able to find it. And the second should be, is it relatively simple for me to do? And does it provide me with a way to include all the documentation I just spent all my time creating to make sure that I can include that too? So again, when you're sharing, you want to think about the difference between access, which is your data dumpster, versus meaningful access. So again, from this study, I could have just shared the spreadsheet and that's it, but no one would have understood what those spreadsheets meant. So it includes a data dictionary, all my documentation, it's all there as well. So thinking about that publication, all that other content should come into play when you're thinking about publishing anything. So ultimately, where the data management process comes in is you have your publication on the left-hand side, and then you gather all of your data management material. That's my data sets or my information about my data sets, my surveys or what I used to collect it, how I conducted my study. If I had consent information, I put that there, data management plans. All that information is organized and saved in one place, and I put that in a repository. So it's not just my data, it's everything else, so that my data is understandable to other people. Something else that is important to mention, because when you're collecting data, I mentioned before, during the preservation phase and during the storage phase, it's important to think about what kind of data you have, is that not all data should be shared publicly. So two of the main questions you should ask yourself is, does this data reveal anything about who it was collected from? So if I'm collecting interview data, for example, from people, or I have patient health information, I may not be allowed to share that data without the consent of the people who I collected that data from. So you need to think about, can I ethically and legally share this? And if you are working with patients or with people, potentially vulnerable populations, and you want to share that data, you need to ask them at the outset and think about that. So before you start your project and you're building consent forms, that needs to be included so someone can either agree or disagree to share. And you have to respect that right. And certain individuals and certain groups have created entire policies around this. And one of that is the OCAP principles for Indigenous data. So if you're ever working with Indigenous communities around collecting research data, Indigenous communities talk about ownership, control, access, and possession of their own data, and they get to dictate how their data is shared and with whom. So it's important, again, for you to think about, depending on what population you work with, there may be parameters that you're working within. And before you go and share, that you have reasons why you can or cannot share. And if you can't share and you're trying to publish in a journal, this is an example of where you can provide justification as to why you cannot share your data. So it's not always going to be possible, but the goal is to make this as much as we can available so our research process is transparent. So I wanted to sort of wind things down here with showing you a gold standard that I think is a gold standard for data sharing and data management in a real world example. So this is from the Collaborative Research in Computational Neuroscience Research Group. And what they've done is created a website where all their data is available. What they've done is created all of the content I just talked about today in a very easy and digestible way. So first of all, they have all of the documentation, which is basically like a README file of their data up front at the outset. It gives me a summary of what they collected and what's included inside the data. It tells me the format of the data and how big the data is. It's showing me how I can gain access to that data. And it's even telling me how to give credit when I use it. So it's really covering all of its bases in terms of making sure I know exactly what's happening in this research project so I can grab the data very easily. From there, they have an entire data inventory that describes all of the different data included, what types of files, how much data, how frequently they're updated. It's all there and available for me and easy to understand. And they also have a data processing workflow. So that data collection plan is all available here. It shows me the experiment they run, the files it produces. It's all there, easy for me to see in one nice package. So this is really the ideal of what every data set should look like if you're sharing it and making it available. And then finally, it's telling me exactly, here's how I access it and here's how I download it. So just to summarize and wrap up and make sure we have time for questions, data management is something that you should address before beginning a study. All of the things we talked about are so much harder to do if the study is over. So the more you think about this beforehand and think about it throughout, the better chance you're going to be to stay organized, to make things transparent, and be able to produce the documentation you need. Remember, data management is not a fixed process. Things change, research is fluid, and ultimately what you're going to need to do is adjust over time, and that's fine. But the important thing is that you're still considering other people and the idea that your data and your information is going to be shared with others before you start your process. Again, if you only take away some things from this presentation, any documentation that you create is better than none. So definitely think about that. And if you have certain things that resonated with you today, try that first and see if that helps you. But ultimately, what's also important in this case is that you may be someone who really cares about data management on your team, but you need to convince the others that you work with that it's important too, and everyone needs to be on board. Otherwise, it's much harder to do. So again, ask yourself, what would someone need to know to understand your research? Document it, document it, document it throughout the process. Protect your data by storing it and making sure you can preserve it for the long term, and be sensitive to who and where you're collecting your data from. So just some tools I think that are useful for you to get started. There are some great resources from the Portage Network on planning and managing your data. I have an institutional research guide here, and I'm going to share the slides afterwards no matter what, so don't worry, you'll have this as a guide for yourself. But other tools you can use are the DMP Assistant. Now, Portage has created this, and I'm going to share my screen, to allow you to create your own data management plan in a tool. So I can create my plan details, and what it's going to do is ask me questions about how I collected my data, how I documented it, how I'm storing it, preserving it. And this allows you to go step by step through the process yourself at the beginning of your project to make sure that you answer those questions. Then you can export this as a document, like a PDF file or a Word doc. So a really, really helpful tool if you want to implement data management right away. The other tool is if you're considering making your research more open, the idea of open science, or really opening up our whole research process, is becoming more and more common. And what it allows you to do is to share your data as you work through your research process. So it's a website that also allows you to get credit for the work that you do. And I'll just show you an example of my own research, which is currently underway, which you'll notice that I have a description of my data. I already have all the methods for what I'm doing, my data dictionary, my study protocol, my analysis plan, and I've already shared my raw data, even though I haven't published yet. And the reason for this is I'm trying to encourage people to think about keeping all the research open as much as possible, because if anyone wanted to use this, they would still have to cite it. And it allows me to have a citation here. I can bring in other collaborators to work on it. And we can actually use this as a tool, as part of the research process to work on throughout the process. So very, very helpful here. I can also see who's accessed my data and change files in here. It links up to all the different research programs. It links up to Google Drive. So I highly encourage you to take a look at this as well if you can. Here are some references of the things I talked about today. You're welcome to take a look at them. I again highly recommend you look at John Borghi's article at the very top, and Everyone Needs a Data Management Plan from Nature. And I'm always here to have questions. I love talking about research data. I want to help researchers work to make their research more transparent, and I'm happy to take questions at this time, but please feel free to reach out to me whenever you have questions in the future. And that's all I have. 4 minutes to spare. Great. So, okay, let me open up the chat so I can start to see what's happening. So the best way to create a README file is to create a plain text file. So everyone's web page should have a notepad. I don't know if you guys can see this, sharing my screen. Yeah, and John, I'm going to share the slides. This tool is actually, this whole presentation is meant to serve as a step-by-step guide for you to start this process. So I encourage you to use that. But for Mira's question, I would open up a notepad and I would start with my description and I'd start writing it in. I'd start writing about data collection process, who is responsible, and that's what I would do. And then I would save it. And I would say, okay, I'm going to save it on my desktop. And maybe this is Kevin data processing README. So I just always append it with a README file, and it's always a TXT, because you can open up a TXT file on any computer anywhere.
That's awesome. Does anyone else have any other questions? It's a quiet group, but there were a lot of people who were here the whole time. Yeah, 59 at the very top. It was fantastic. I'm going to stop the recording if anyone still has any further questions. And of course, our good Canadian kids, they're saying thank you, thank you, thank you.
Yeah, appreciate it.
Yeah, no, they're excellent. Kevin, thank you very, very much. And we will be posting this online, and Kevin will be sharing the slides with me, and I will send it to everyone. And thank you very much for joining us today.
No problem. I'll just say it's I am Canadian, and it's just wonderful to be back in Canada working in research data and seeing undergrads so interested in it, because I think it really starts with undergraduates. Because now, as you move into doing more research, if you have this as your foundation, you're going to be so set for moving forward. So it's a lot harder to teach old dogs new tricks. Whereas in this case, it's really nice to see people interested and engaged in this. Yeah, Brianne, I'm still here, so you can ask the question if you'd like.